So we're going to do reactions of alcohols. Okay, reactions of alcohols. Right, so the first reaction of alcohols is combustion. They are very good fuels. They release a lot of energy. Exothermic, release a lot of energy when combusted. So if we take, for example, this alcohol, okay, structural formula is propan, and the alcohol is on carbon 1, propan 1-ol, and when we combust this alcohol, complete combustion in oxygen, again we get carbon dioxide and water. Okay, propan 1 is a liquid, oxygen is a gas, carbon dioxide is a gas, and water initially it'll be a gas when you combust it, steam, but I'm going to put it as a liquid in its standard form. Okay, so we balance the carbons first. There are 3 carbons, so we go 3 carbons. We balance the hydrogens next, so there are in total 3, 5, 7, 8 hydrogens, so we need 8 hydrogens there, and then you do the oxygens last. So there are 6 and 4 is 10. We need 10 oxygens. Now do not forget there is an oxygen here, 1 oxygen, so you only need 9 oxygens, so you can either put 9/2 or 4.5. Okay, it's very easy to forget this oxygen here, and this is the complete combustion of an alcohol. Don't forget as well that alcohols are not hydrocarbons, because what's the definition of a hydrocarbon? A hydrocarbon contains hydrogen and carbon only, so they are not hydrocarbons. Okay, so that's the first reaction. The second reaction of alcohols is a reaction called oxidation. Okay, oxidation. Now, this is when you take a primary alcohol and you oxidize it to an aldehyde. Okay, we're going to show this in action. So we're going to take a simple alcohol. I'm going to just draw it out really clearly. Simple alcohol. Okay, an alcohol, and we're going to turn it into, it's called an aldehyde. Right, so you've got 2 carbons, so the 2 carbons, okay, and then the 3 H's, so they're exactly the same. Okay, but instead here, we're going to remove that hydrogen, and we're going to put a double bond O. Okay, and then also we've got this hydrogen is still there as well, and so we're actually removing that hydrogen and that hydrogen. Okay, 2 hydrogens, and that is called an aldehyde functional group. Okay, can you see that carbon still has 4 bonds, and that is called, so this is called ethanol for alcohol. This is called ethanal for aldehyde. All right, now for oxidation, this is called oxidation. It's quite complicated what's actually happening, so we just put an O inside square brackets, and this means that an oxidizing agent has been added. Okay, because it's quite complicated, an oxidizing agent has been added. So can we see, to balance the equation, we lost a H, and we've got an O, so it is plus water. And this is called oxidation. And this is mild oxidation is what it's called. And the conditions are distill, okay? Distillation is when you have a round bottom flask or a pear-shaped flask, round bottom flask, you have I'm not very good at drawing, you have a condenser, called a condenser. You'll do this in your practicals, and there'll be a thermometer on the top. Okay, so this is called a condenser. Sorry, rubbish at drawing. Okay, water in the bottom, water in and water out. Okay, and your chemicals are in your round bottom flask, and so you heat up the chemicals. The chemicals come up here. The thermometer is just checking the temperature. And then they hit the cold water jacket of the condenser, and the chemicals drip down here, and then they're collected in some container at the end. So that's distillation. And so as soon as the aldehyde is made, it is removed straight away. Okay, and that's what happens with primary alcohols. Now let's talk about this oxidizing agent. An oxidizing agent that we use is acidified, right? Normally use sulfuric acid, acidified potassium dichromate. Acidified potassium dichromate, okay? Acidified potassium dichromate. Now, what's the oxidation state of the chromium? Chromium can have different oxidation states, so you've got to be able to work it out for each one. What's the oxidation state of chromium? Okay, well, if oxygen is -2, and there are 7 of them, oxygen is -2, that's -14. Potassium is in group 1, so that's oxidation number +1, and there's 2 of them, so that's +2. So we need to total 0 because there's no charge. So therefore chromium must be +12, but there's 2 chromiums, so each chromium is +6. So the chromium has an oxidation state of +6, therefore we put in brackets at the end in Roman numerals V1, which means 6. So that means that the oxidation state of the chromium is 6. Okay, acidified potassium dichromate. Now, this is the oxidizing agent, right? This is the oxidizing agent, the chemical that is added. And you need to know that the starting color, so the observation, and you're going to do this as an experiment as well. It's going to be one of your set experiments. So if you take potassium dichromate, now I'm going to take off, okay, I'm going to take off the potassium ions, okay, and I'm just going to write the dichromate, because it doesn't have to be potassium, it can be sodium dichromate as well. Now this is the color orange, and remember chromium is in the +6 oxidation state here. Okay, what happens as the reaction happens? Okay, the alcohol, the primary alcohol, is oxidized. Do you remember what that functional group is called? To an aldehyde. So if something is oxidized, the other item needs to be reduced. Okay, so the chromium is reduced to the oxidation state +3. Okay, so it's gone down in oxidation number, and this is the color green. So when you do this reaction, it goes from orange to green, and that's the color change. All right, let's try another example quickly. So if you take ethanol, okay, and it's mild oxidation, and you add your oxidizing agent, and I'm going to write the oxidizing agent over the arrow. I'm going to write potassium dichromate, and we need acid in there as well, okay, and it's mild oxidation. I'm just going to distill it. Mild oxidation, it goes to an aldehyde. There are 2 carbons, and then we are going to form an aldehyde, which is a C double bond O H. Carbon's got 4 bonds and then H. Okay, I've just realised I've done exactly the same example again. I'm sorry, I didn't mean to do exactly the same example again. And water. And the water is that, and that. And the colour change is orange to green. I didn't mean to do exactly the same example. Right, let's take something else, right? If we take, let's just take the same thing again. If we take ethanol, right, and instead we do a complete oxidation, we do further oxidation, okay? So a primary alcohol can be oxidized to an aldehyde, okay? But if you take it further and heat it some more, you can turn it into a carboxylic acid, okay? And in order to do this, so that is distill, but in order to go all the way to the other end, we need to reflux. Okay, now my drawing is not very good, but again, you take a round bottom flask or a pear-shaped flask, and then you put the condenser. The condenser goes upright, so not to the side like in distillation. The condenser goes upright, and that water goes in at the bottom, and water comes out the top. Okay, and then you've got your chemicals in the flask, and then you heat it up, and what happens that it evaporates, hits the cold condenser and turns back into a liquid. So reflux is the continuous evaporation, boiling, evaporation, and condensation. And it's all heating within the flask, okay? So none of it is escaping. It's all heated within the flask. Now when that happens, so we turn it into, so two carbons, we have a carboxylic acid. It looks like that. Okay, be really careful with your drawing. Okay, that's a carboxylic acid, and we need all the on the H's. Okay, and then because we are oxidizing it twice, we're oxidizing it to an aldehyde and then to a carboxylic acid. We need 2 oxygens, and we need to balance it. So still again, we've lost these hydrogens, and we have an O, and so it's water. Okay, this is ethanol, and this is called ethanoic acid. Okay, we'll do more about this on carboxylic acids. We need to do more about it, but it's called ethanoic acid. All right. So oxidation. So that's the primary alcohol, right? And the color changes orange to green. Okay, I'm just going to summarize it here. Primary alcohol can be oxidized to an aldehyde first, and then it can be oxidized to a carboxylic acid. Okay, what about if we take a secondary alcohol? What happens then? So I'm going to take secondary alcohol. I'm going to take this alcohol. Remember, a secondary alcohol, how to classify it. The carbon that's joined to the OH has got 2 other carbons joined, and this is called propan, and it's on carbon 2, propan 2R. Okay, now when you oxidize propan 2R, so you've got 3 carbons, okay, nothing happens to the carbons at the end, nothing happens to them. It all happens on the carbon that's joined to the O. It all happens on that carbon. So just the same, we form a double bond O, okay, a double bond O. But can you see how many bonds carbon has got? 1, 2, 3, 4. It can't have any more hydrogens. So this hydrogen, and O becomes water. Okay, now this functional group, the part of the molecule that is responsible for the chemical reactions, is called a ketone. Okay, and this is called propanone for ketone. Okay, propanone. Okay, so secondary alcohol forms a ketone, and it cannot be oxidized any further because there's no hydrogens left on the carbon. So it stops at a ketone and cannot be oxidized further. Okay, the last type of alcohol is a tertiary alcohol. And again, the colour changes orange to green for secondary alcohol. Tertiary alcohol, what happens then? So let's take a tertiary alcohol. Careful with your connectivity. H's all around. H's. Just quickly draw them all in. Okay, do you remember what this one is called? Propan 2-ol, because it's on carbon 2, and it's on carbon 2, we've got 2-methyl. Whoops, 2-methyl. Okay, when you oxidize this, okay, you've got, draw the carbon skeleton. Okay, so we need to remember everything happens on the carbon joined to the O, and we need to form a double bond O, because that's what happened in all the other examples. We formed a double bond O. But this cannot happen because carbon has got 5 bonds. This cannot happen because there's not enough bonds. So oxidation of a tertiary alcohol does not happen. Does not happen. Okay? So just the primary alcohol, the secondary alcohol that is oxidized. Let me just quickly do summary underneath here as well. An aldehyde is the functional group, double bond O, H. That's an aldehyde. Carboxylic acid, and you need to learn these, is that. And a ketone is in the middle of the molecule like that. Okay, a ketone. Right, that's oxidation of alcohols. The next reactions, 2 more reactions. We've done combustion, we've done oxidation. The next one is dehydration of alcohols. Okay, the next one is dehydration of alcohols. Sorry, dehydration of alcohols. Do you know what the word dehydration means? Dehydration means removing water, sometimes called elimination of water. So it's when you take an alcohol. So let's take this alcohol. I'm just drawing it very clearly so you can see it. And there are H's all around, okay? Do I need to draw them all in? Whoops. Let me just quickly draw them in. Don't be lazy. Okay, so what's that alcohol there that we've named? Okay, so that, we've drawn, sorry. So that is butan 2-ol. Okay, now you need a catalyst. It's heated under reflux, and you need a catalyst which is a concentrated acid. And now quite often it is sulfuric acid, but it also can be an acid called phosphoric acid. It's called phosphoric acid. You use either of those acids, okay? And it eliminates water and removes water. Okay, eliminates water. Now, what it does, it eliminates the OH and the H of the neighbouring molecule. Okay, so it eliminates the OH and the H of the neighbouring molecule, of the neighbouring carbon atom. So it takes away those. Now when it takes away, there's the water, you've got your 4 carbons. Okay, got H, 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 and H, 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 H. Alright, so it takes away the water. But can you see now, carbon does not have enough bonds. Carbon has to have 4 bonds. So it puts in its place a carbon-carbon double bond, which is called an alkene. Okay, an alkene, functional group alkene. This would be called, there's 4 carbons, this would be called but1e. I know we've not done alkenes yet, but I'm introducing a lot of functional groups to you here in one section, okay? And but there's another issue with this, because it may not take that, it may take this instead, okay, instead, and if that happens, if it eliminates that instead, you've got your 4 carbons, you've got to put all your hydrogens on. Oh, sorry, handwriting's not very good. Okay, so if it's eliminating that instead, that one instead, the carbon-carbon double bond is there, and that is called but2e. So you get a mixture of products because it can eliminate water at either side. So it's called dehydration of alcohols. This is where you're going from an alcohol to an alkene plus water. Okay, last reaction, really quick, only one more to go. Dehydration of alcohols. The last one is the substitution of alcohols. Right, substitution of alcohols. Substitution of alcohols. Okay, so this is when you take if you take, let's take for example, I don't know which example to take. Let's just take propan 2-ol. It doesn't matter which example we take. Let's take propan 2-ol. Okay, and what we can do is we can substitute the OH for a halogen. If you add HBr, and it's down under reflux as well, it's heated under reflux, a substitution happens. So the carbon skeleton is the same. Just draw the carbon skeleton exactly the same, but instead of the OH, we replace it with a Br. And then the other product is water plus water. Okay, and this is called a haloalkane. It's called different things. It can be called haloalkane. We used to call it halogenoalkane. It's a halogen and an alkane. Okay, its actual name here is 2-bromopropane, and it's a substitution reaction, right? But that's not actually what happens, because when you practically do this, the first thing you do is you heat together sodium bromide and sulfuric acid, and that makes HBr in situ. Okay, in situ, which is short for in situation, which means you use it, you make it and you use it straight away. And the other product here is, if you take off the H and the Br, you're left with Na, sodium hydrogen sulfate. So that happens first, and then that is reacted with the alcohol. So overall, if you were doing a proper overall chemical equation, you would show your alcohol, which is propan 2-ol, plus NaBr, plus sulfuric acid, and then that gives you your halogenoalkane. I'm just using the same example, plus blah blah blah, what's the other product? Sodium hydrogen sulfate plus water. And that's the overall chemical equation. Okay, overall chemical equation for the reaction that I've just done up there.